When we talk about Calculus BC, we're going to be using trig quite a bit throughout the year. And what we want to do today is review trigonomic functions and how we're going to calculate them. A lot of times we'll be able to use our calculator, but not always. Sometimes we'll have to do things in our head. So let's look at f of x here. We have f of x is equal to the square root of x. That's pretty easy to calculate for f of 4. Of course, f of 4 is just going to be equal to the square root of 4, which is equal to 2. And f of 9 is also easy. That's going to be the square root of 9, which of course is equal to 3. But if we have f of 6, well, that's going to be quite a bit more complicated. We'd have to use the square root of 6 and use our calculator to calculate that. And likewise, if we used f of 8.124, we're going to have to take the square root of that, and that's going to be more complicated as well. So let's look over here at g of x. Sine of x is going to be complicated if we find g of 1, g of 2. Well, sine of 1, we don't really know how to find. Sine of 2, we don't really know how to find. And likewise, we don't know how to find sine of 0.5236. But if I told you that 0.5236 is actually equal to pi over 6, then that information is useful in knowing that this is a trigonomic value that we could actually find very easily in our heads. Likewise, g of 2.094 would be 2.094 would be not just the sine of 2.094, but rather the sine of 2 pi over 3. So how are we going to find these? We can use the unit circle to do so. So the unit circle gives us an opportunity to quickly and easily find values. And I'm going to label some points here. Here, this value on the unit circle is equal to 0, and we're measuring in radians, of course. This value is equal to pi over 2. Here, I'll zoom out a little bit. Here, we're equal to pi. Here, we're equal to 3 pi over 2. You see that all right? We can also divide this into quarters. So if I measure about right here, this would be pi over 4. About right here, well, this would be pi over 4. This is 2 pi over 4. Here we have 3 pi over 4. 4 pi over 4. 5 pi over 4. 6 pi over 4. 7 pi over 4. And 8 pi over 4, which is just equal to 2 pi. And I do want to mention here that 0 and 2 pi are located at the same point on the unit circle. We can break this up even further, or not even further yet, I guess, but let's first talk about breaking this into thirds. If we break this into thirds, we have pi over 3 is about right here. Then this is 2 pi over 3. 3 pi over 3. 4 pi over 3, 5 pi over 3, and 6 pi over 3. We can also talk about, and I'll use light blue here, breaking this into sixths. So this would be pi over 6, 2 pi over 6, 3 pi over 6, would be here, right? Yes. 4 pi over 6, 5 pi over 6. 6 pi over 6, 7 pi over 6. 8 pi over 6, 9 pi over 6, 10 pi over 6, and 11 pi over 6. So this is our unit circle, and this is how we're going to calculate values of sine, cosine, and tangent. So let's look down here. If I'm asked to find sine of pi over 6, cosine pi over 6, tangent pi over 6, well, there's some information I need to know before I dive into that. X and Y can be thought of as cosine theta, comma, sine theta, when we're talking about trigonomic functions and radians. And also, when we talk about these, tangent, I want to mention that tangent of theta is equal to sine of theta over cosine of theta. And there's three parts that you're going to want to pay attention to. When we have like a short distance, that's going to be equal to 1 over 2. A medium distance would be equal to radical 2 over 2. And a long distance will be equal to radical 3 over 2. Okay, what do I mean by that? Well, let's look here back again at sine of pi over 6. Sine of pi over 6 is right here. Sine is going to be my y value. My y value, of course, goes this direction. So my y value is a short distance here. So sine of pi over 6 is just going to be equal to 1/2. Cosine of pi over 6 is again right here. Cosine of pi over 6 is my longest distance, right? I have a long distance, a medium distance, a short distance for cosine. For sine, I have a short, a medium, a long distance. So for cosine of pi over 6, I'm traveling my longest distance. My longest distance is going to be radical 3 over 2. And tangent of pi over 6, you saw that I mentioned earlier, the tangent of theta is equal to sine of theta over cosine of theta. So sine of pi over 6, we already found, was 1/2. So this is going to be equal to 1/2 over radical 3 over 2, which of course is equal to 1/2 times 2 over radical 3. The 2's cancel out, which is equal to 1 over radical 3, and we don't want to have radicals in our denominator, so this is equal to radical 3 over 3. So I want to take note here of what our tangent values are. So here, tangent is going to be equal to tangent theta is equal to radical 3 over 3. Here, tangent theta is equal to 1. And here, tangent of theta is equal to radical 3. At 2 pi over 3, tangent theta is equal to negative radical 3. At 3 pi over 4, tangent theta is equal to negative 1. And at 5 pi over 6, tangent of theta is equal to negative radical 3 over 3. And that makes sense because here our cosine values are going to be negative on our x-axis here, but our sine values are still going to be positive. So if you put cosine over sine, you're going to have negative over positive. You're going to get negative values here. Down here, I'll just fill these out. These are almost the exact same. You can see how these are working. And here, 5 pi over 3, again, we have, did I do this one right? Radical 3, yep. Tangent of theta equals negative 1. These values are going to be negative again. So that's how we use the unit circle to calculate these values without actually having to use our calculator. So let's move on and talk about our inverse trig functions, or not rather our inverse, but our secondary trig functions, excuse me. So our secondary trig functions are, of course, cosecant, secant, and cotangent. And cosecant of theta is just equal to 1 over the sine of theta. Secant of theta is equal to 1 over cosine of theta. And cotangent of theta is 1 over tangent of theta. Easy enough. So if we were asked to find cosecant of, let's say, we'll do pi over 3. Well, that's going to be equal to 1 over the sine of pi over 3. And sine of pi over 3, remember with our unit circle, pi over 3 is right here. Sine, that's our tall one, so we're going to have 1 over radical 3 over 3, which is equal to 3 over radical 3, multiply out, and we're going to get, what, 3 radical 3 over 3, which is just equal to radical 3. We could do the exact same for secant and cotangent, but that's really all there is to it to simplifying and finding these values.